Hi friends, in this video we will be looking at alloys. Mostly alloys are composed of two or more chemical elements of which at least one is a metal. So you take any metal that you encounter mostly in your day-to-day life. Let's say it is steel, whether let's say it is brass or bronze, all these things are basically alloys. Having said the relevance of alloys, now coming to the structure in which or the form in which we can see most of the alloys, there are basically two forms in which alloys exist. The first one is a solid solution. First one is a solid solution. The next one on the list is intermetallic compounds. Intermetallic compounds. Now, mostly in this week or in this particular video, I will touch upon the solid solution part. That doesn't mean intermetallic compounds are less significant. They are definitely significant, but for this particular course, my emphasis will be on solid solution, or alloys which exist in the form of a solid solution. Even within solid solution, there exist two categories. The first one is substitutional solid solution. Substitutional, I hope I get the spelling right. Substitutional solid solution. And the next one is the interstitial solid solution. Make sense? Now, before we go deep into the description of all these things, first of all, what is an alloy? You can pause the video for a while and then come back to me with the definition. So, alloy is basically a compound of two or more chemical elements, of which two or more chemical elements in which at least one is a metal. So this is a very basic definition of an alloy. So we just now described that alloy can be classified into substitutional solid solution as well as intermetallic compound. Now, first one on the list is solid solution. So what is a solid solution actually? From the word solution itself, there will be two things. One is the solute and other is solvent. Now, the peculiarity of a solid solution is that the solute and solvent, both of them are solids, and moreover, when the particular crystal structure of the solvent will be in abundance compared to the solute. So if the crystal structure of the solvent is maintained during alloying, then that alloy is called a solid solution. So the key thing to note here is that the crystal structure of the solvent is maintained. Okay, now we told that in substitutional solid solution, let me erase this portion. There are two types of solid solution, not substitutional solid solution. There are two types of solid solution, and one among them is a substitutional one, and the other one is interstitial. The name itself describes what will be the difference, but even then I will give you a formal definition of both these types of solid solution in a while. First, let's start with substitutional solid solution. So coming to substitutional solid solution, from the name indicates, as the name indicates, What happens in this type of a solid solution is the size of the solute atom is comparable to that of the solute atom. So once you add the solute metal into it, what happens is, since the sizes are comparable for the time being, let's say I have all those four dark atoms. This is the initial configuration. Once you add the solute into the solvent, the resulting combination will be something like this. So let me take an example. So first of all, brass is an example for substitutional solid solution, which is an alloy of copper and zinc, as all you may be knowing. So let's say these are all copper. Here also copper. Now here comes the solute zinc. In this case, since both of them are comparable, it forms a solution like this. Actually, it can replace a solvent atom. Zinc, which is a solute atom, can replace a solvent atom. So for this, there are certain conditions that should be satisfied to form a complete substitutional solid solution. Now we will be talking about that. Those are called Hume-Rothery rules. They are pretty much common sense rules, I would say, because here are the two rules. The first rule goes like this: the two metals must have their similar crystal structure, because as you have just seen, solute atom is replacing a solvent atom, so you can't have two different crystal structures. The solvent and the solute can't have two different structures for the same to happen. So they should share the same crystal structure. In this case, both copper and zinc share the FCC structure. And the other thing is that the difference in atomic radii should be less than 50%. If you remember the position of copper and zinc in the periodic table, then you will come to know that they are more or less of the same size. I mean, the atoms are more or less of the same size. So these rules should be satisfied for the successful formation of a substitutional solid solution. Now in the next lecture we will talk about interstitial solid solution and the other type of an alloy form called intermetallic compound. Thanks.